Can continue, children. If 1 plus I by 1 minus I whole raised to m is equal to 1, find the least positive integral value of m. This 1 plus I by 1 minus I is a complex number. Its raised to m is equal to 1. So, what is the least minimum integral positive integral? Integral value means integer. Minimum, the least positive integer. What is the value of m? The least positive integer value we have to find. So, first we can simplify this. Okay, 1 plus I by 1 minus I. It is not in the standard form a plus ib. So, the denominator is an imaginary number, we have to rationalize. So, multiply by the conjugate 1 plus I, denominator 1 minus I into 1 plus I. So, the numerator is 1 plus I whole square, denominator a minus b into a plus b, a square minus b square. So, the numerator is a square plus 2ab plus b square by 1 minus minus 1. Then the numerator 1 plus 2i, I square is minus 1, that cancel. 1 plus 1 becomes 2, or 2i by 2, that's equal to I. Okay. Now, this raised to m. So, what is it? 1 plus I by 1 minus I whole raised to m, that is I raised to m. Okay. And this is given as what it is given? It's equal to 1. So, this is equal to 1 implies I raised to m is 1. So, what is the value of m? We know that I raised to 4k, the multiple of 4, that is always 1. So, m we can write 4, 8, 12, 16 like that, which is the least minimum positive integer. So, we can write m is equal to 4. If m is equal to 4, I raised to 4 is 1. Okay. I raised to 8 is also 1, but we have to write least positive integral value. So, m is equal to 4. Find the number of non-zero integral solutions of the equation. Modulus 1 minus I raised to x is equal to 2 raised to x. How many non-zero integral solution? Integral means integer. How many, other than 0, how many integer solutions are there for this equation? So, here it is a complex number 1 minus I. What is modulus of 1 minus I? Modulus of a complex number is equal to root of real part square, 1 square plus imaginary part. What is imaginary part? Minus 1. So, minus 1 square, that is 1 plus 1, that is equal to root 2. So, modulus of this complex number is root 2. Now, we can substitute there. So, 1 minus I modulus raised to x is 2 raised to x. That implies modulus value is root 2. So, root 2 raised to x is equal to 2 raised to x. Root 2 we can write as 2 raised to half. 2 raised to half raised to x is 2 raised to x. So, which implies 2 raised to x by 2. 2 raised, we can multiply the power, a raised to m raised to n is a raised to mn. So, 1 into x, x by 2 is equal to 2 raised to x. Now, base are equal. If a raised to m is equal to a raised to n, base are equal, we can say that m and n are equal. So, which implies the powers are equal, x by 2 is equal to x, or x is equal to 2x, or 2x minus x is 0. So, what is x? X is equal to 0. X is equal to 0. So, 0 is the solution of that given equation. 0 is a solution. Other than 0, no other solutions. So what is the question? What is the number of, find the number of non-zero integral solutions. So here we got the solution as 0, no other solutions. So what is the number of non-zero integral solutions? That's equal to 0, no other integral solutions. So number of non-zero integral solutions. That's equal to 0. If x plus iy whole cube is equal to u plus iv, then show that u by x plus v by y is equal to 4 into x square minus y square. So first we can take that x plus iy whole cube is equal to u plus iv. Expand this, a plus b whole cube, that is a cube plus 3a square b plus 3ab square plus b cube is equal to u plus iv. Two complex numbers are equal means real part equal to real part, imaginary part equal to imaginary part. But this is not in the form a plus ib, so we have to again simplify. X cube plus 3x square iy. So this is an imaginary number, plus 3x into I square is minus 1. So it is minus y square plus I cube y cube. So this is the real part. X cube and minus 3xy square. These are the real part. And what is the imaginary part? I into 3x square y. What is I cube? I cube is minus I. Minus I by cube. So we can take outside, then we can equate. So x cube minus 3x square xy square. Put in a bracket, this is the real part, plus I into 3x square y minus y cube, imaginary part, u plus I. So two complex numbers are equal. That means we can equate. So what is u? U is equal to the real part. Therefore, u we can write as x cube minus 3xy square. Or x is common, x square minus 3y square. Or I can write u by x is equal to x square minus 3y square. Okay. The same way, imaginary part, that is v is equal to 3x square y minus y cube. Y take outside. So what is v by y? 3x square minus y square. Then look at the question. We have to show that u by x plus v by y is 4 times x square minus y square. So we have to add, okay, this expression and this expression. So add it, u by x plus v by y. X square minus 3y square plus 3x square minus y square. So that's equal to 4x square minus 4y square. Or take 4 outside, so we get the result. Four into x square minus y square. So that's it. The next one, if x minus iy is equal to square root of a minus ib by c minus id, prove that x square plus y square whole square is equal to a square plus b square by c square plus d square. Here we use the result. We have this property. z bar is equal to mod z square. Okay. So here this is a complex number x minus iy. X minus iy, that's equal to root of a minus ib by c minus id. Okay. Now taking the conjugate of this. What is the conjugate of this? X plus iy is equal to root of, here also take the conjugate. So a minus ib becomes a plus ib by c plus id. So this one, this two. Okay. So a complex number and its conjugate. Then if we multiply z and z bar, we can multiply, so we get mod z square. Okay. So here multiply 1 and 2. Equation 1 and equation 2 you have to multiply. So x minus iy into x plus iy. So next step, z into z bar becomes mod z square. What is mod of z? X square plus y square. Okay. If z is equal to x plus iy or x minus iy, whatever, mod z becomes root of real part square plus imaginary part square. If it is minus iy, then minus y square becomes plus. So mod z square becomes x square plus y square, or you simply multiply. X into x becomes x square, x into iy, ixy minus iyx, that cancelled. Then minus I square y square, that becomes plus y square. And right side. So put a root symbol. Then inside we can write these two. A minus ib by c minus id into a plus ib by c plus id. So here also multiply. Or we can write a minus ib into a plus ib is a square plus b square. Denominator c square plus d square. So this is x square plus y square. But check the question. Without root you have to write. So squaring both sides. Okay. Squaring both sides. Squaring both sides. So x square plus y square whole square becomes a square plus b square by c square plus d square. The next one. If alpha and beta are different complex numbers with mod beta equal to 1, modulus of the complex number beta is given as 1, then find what is the modulus of beta minus alpha by 1 minus alpha bar beta. Alpha bar means conjugate of alpha. So we have to find the value of this value now, modulus of that. So we can start with that, modulus of beta minus alpha by 1 minus alpha bar beta. If it is like this, we can't simplify. So better take mod square. So if it is mod z square, we can write as z into z bar. Okay. So here we have to find the modulus of this expression. So I take that mod square. So that's equal to this complex number beta minus alpha by 1 minus alpha bar beta. Take that as, or consider that as z. So z into z bar. Z bar. So this is z bar. Okay. Mod z square is equal to z bar. That is the result. Here apply. Now the next step, we have to use the properties. Mod Z1, Z2 the whole bar. How can we write Z1 bar by Z2 bar? It's one property. So we can write beta minus alpha bar by 1 minus alpha bar beta, again bar. Okay. Now the next step, beta minus alpha into Z1 minus Z2 the whole bar we can write as Z1 bar minus Z2 bar. These are properties. So we can split and write beta bar minus alpha bar by 1 minus alpha bar beta into 1 is a real number. So for that conjugate, we don't want to put the conjugate. 1 conjugate is 1 itself minus alpha bar. Now what is Z bar bar? Z bar the whole bar is Z itself. Okay. So here 1 minus alpha bar beta the whole bar, that we can write as alpha bar bar, that is alpha itself into beta bar. Is this much clear? First we take mod Z square, that's equal to Z into Z bar. Then Z1, Z2 the whole bar is Z1 bar by Z2 bar. Again Z1 minus Z2 the whole bar is Z1 bar minus Z2 bar, and here alpha bar is alpha itself. Now just multiply. Beta into beta bar minus alpha bar beta minus alpha beta bar plus alpha bar. Just multiplication. Denominator also 1 into 1 1 minus alpha beta bar and alpha bar beta. Okay, I just write in the reverse way. Both are same. I can write alpha beta bar first, alpha bar beta. Now the next is plus alpha bar into beta bar. Now what is alpha bar and beta bar? That is mod beta. Z bar is equal to mod Z square. So mod beta square minus alpha bar beta minus alpha beta bar plus mod alpha square by 1 minus alpha bar beta minus alpha beta bar plus mod alpha square into mod beta square. Then it is given in the question mod beta is equal to 1. It is given. So substitute mod beta is 1. So the first term becomes 1 minus alpha bar beta minus alpha beta bar plus mod alpha square by 1 minus alpha bar beta minus alpha beta bar mod alpha square, mod beta square is 1. Now check the numerator and denominator. It's a complex number. Both are same. All the terms are same. So we can cancel this. Okay. Can cancel it. So what we get? We get 1. So what is the left hand side? Left hand side is beta minus alpha by beta minus alpha by 1 minus alpha bar beta. Its square is 1. Okay. So what is its value without square? Beta minus alpha by 1 minus alpha bar beta. This modulus we can take as 1. Modulus is positive, so take the positive value. Okay.